If you were to travel through the cosmos in a straight line, you would expect to see a relatively uniform distribution of matter. Stars, gas clouds, stellar nurseries, and massive spiral galaxies spinning in the dark. This is the baseline of our reality. But if you were to point your ship towards the constellation Boötes and travel for millions of years, you would eventually cross an invisible threshold. Suddenly, the stars would begin to vanish behind you. The distant galaxies would shrink into tiny, isolated points of light before fading altogether. You would enter a region of space so empty, so vast, that the word nothing ceases to be a description and becomes a physical wall. This is the Boötes Void, a spherical expanse of absolute nothingness approximately 330 million light years in diameter. To put that in perspective, the observable universe is filled with cosmic filaments, a web of matter connecting galaxies like neural pathways. But here, the web is severed. The filaments are gone. In a region of space this size, standard cosmological models dictate there should be at least 2,000 galaxies. We have found only 60 tiny, lonely islands of matter floating in a dark ocean that takes 330 million years for light itself to cross. How did a hole this large form in the fabric of the universe? Why is it so perfectly spherical? And what does its existence mean for the laws of physics that are supposed to govern the evolution of the cosmos? Prepare to look into the abyss, because the Boötes Void is not just empty space. It is a cosmic scar that suggests the universe is not working the way we think it is. To understand the scale of the anomaly that is the Boötes Void, we must look at the universe on its largest possible scale. Cosmologists operate under a foundational rule called the Cosmological Principle. It states that when viewed on a sufficiently large scale, the universe is both homogeneous and isotropic. Homogeneous means that no matter where you go in the universe, it will look roughly the same. The density of matter is uniform. Isotropic means that no matter which direction you look, the distribution of galaxies and stars remains consistent. There is no preferred direction, no center, and no edge. This principle is not just a philosophical assumption. It is the mathematical backbone of general relativity and the Big Bang theory. It allows us to write equations that describe the expansion of the entire cosmos as a single, cohesive system. In the infant universe, matter was distributed almost perfectly evenly. But tiny, subatomic quantum fluctuations created regions that were slightly denser than others. Over billions of years, gravity acted on these dense pockets, pulling in more gas, forming the first stars, the first galaxies, and eventually the massive clusters we see today. This gravitational clustering created the cosmic web. The web is made of long filaments of dark matter and hydrogen gas. Galaxies form along these filaments like beads on a string. Where the filaments cross, massive superclusters of galaxies are born, and in the spaces between these filaments lie voids. Voids are a natural part of cosmic structure. As gravity pulls matter toward the dense filaments, the regions between them are emptied out. Standard voids are typically tens of millions of light years across. They are common, expected, and accounted for in our models. But the Boötes Void is different. It is not a standard gap between filaments. It is a supervoid. It is so immense that it spans nearly 0.27% of the diameter of the entire observable universe. If the Milky Way were a single grain of sand, the Boötes Void would be a hollow sphere the size of a 3-story building. According to the laws of gravitational instability and cosmic evolution, a void of this scale simply should not have had enough time to form since the Big Bang. The universe is 13.8 billion years old. To clear out a region of space 330 million light years wide through gravitational attraction alone would take far longer than the age of the universe. And yet, there it sits. A cosmic desert that defies the timeline of creation. Let us enter the void. Imagine steering your spacecraft into this expanse. In normal space, the night sky is a brilliant tapestry of stars. Even in the deepest intergalactic space, you can look in any direction and see the glowing spirals of distant galaxies. But as you cross the threshold of the Boötes Void, the light begins to die. If you were to stand on a planet orbiting a star in a galaxy located at the absolute center of the Boötes Void, you would look up at a night sky of terrifying absolute darkness. You would see no stars, no nebulae, no nearby galaxies. For thousands of generations, your civilization's astronomers would look out into the night and conclude that their solar system and their single galaxy was the entirety of existence. They would have no concept of a wider universe. Indeed, astronomers have calculated that if the Milky Way had been located at the center of the Boötes Void, we would not have discovered that other galaxies existed until the 1960s. Our telescopes would simply not have been powerful enough to detect the faint, incredibly distant light of the galaxies residing at the void's edge. We would have believed we were utterly, cosmically alone. How does such a region exist? One theory proposed by astronomers is that the Boötes Void was not formed as a single giant structure. Instead, it may be the result of a merger between smaller, standard-sized voids. Like soap bubbles in a sink, these empty pockets of space may have expanded until their walls touched, eventually popping and merging into a single colossal supervoid. But this explanation has a dark side. If voids are merging, it means the filaments of the cosmic web, the very structures that hold galaxies together, are being broken. Galaxies that once resided on the walls of these smaller voids would have been flung outward or torn apart by the changing gravitational landscape. And the 60 galaxies we do find inside the void, they are anomalies within an anomaly. These galaxies are not normal. Many of them are shaped like pristine, undisturbed spirals. They have not interacted with other galaxies for billions of years. They are cosmic relics, floating in a state of suspended animation, untouched by the gravitational collisions that shaped the rest of the universe. But some of these galaxies also possess massive, active galactic nuclei. They are emitting powerful jets of radiation, powered by supermassive black holes. Why would the emptiest region of the universe host galaxies with such highly active, energetic cores? What is feeding these black holes in a realm where there is no gas, no dust, and no neighboring matter to consume? The existence of the Boötes Void suggests that our cosmological models have a fundamental flaw. If the universe cannot naturally produce a void of this scale in 13.8 billion years, then our understanding of gravity, dark matter, or the Big Bang itself is incomplete. But the implications go deeper, into the realm of cosmic existential dread. What if the Boötes Void is not a natural structure? In 1964, Soviet astronomer Nikolai Kardashev proposed a scale to measure the technological advancement of a civilization based on the amount of energy they can harness. A Type 3 civilization is one that can control the energy output of an entire galaxy. But what if a civilization progressed beyond Type 3? What if a Type 4 or Type 5 civilization emerged capable of manipulating matter and energy on a cosmological scale? If a civilization were to harvest the energy of entire galaxy clusters, dismantling stars, redirecting gas, and containment shielding the radiation, they would leave behind a region of empty, dark space. Over millions of years, as their energy demands grew, the boundary of their harvesting zone would expand. They would create a void that is perfectly spherical because the expansion of their technology would propagate outward at a uniform speed in all directions. Under this hypothesis, the Boötes Void is not an empty space. It is a quarry, a region of the universe that has been mined clean of its matter by an intelligence so vast that we cannot even begin to comprehend their utility. The 60 galaxies left inside, they could be nature reserves, or simply remnants that were not worth the energy to harvest. Whether the Boötes Void is a natural anomaly that breaks our physics, or the footprint of a civilization that operates on the scale of gods, the reality remains the same. Space is not a uniform, welcoming expanse. It is a canvas of extreme, terrifying variations. And as we look out into the night sky, we must confront the possibility that we are not living in a typical, average corner of the cosmos. We may be living on the edge of an abyss, a 330 million light-year dead zone that is slowly, silently waiting